So now let us see now mission to mission. Mission to, who are the missions? Now what are the missions? Who are the missions here? Madam, how many faculty are here? You are faculty, madam? You are the faculty? So what exactly the mission to mission here? Internet of Things is there, yes? What is the mission to mission? Who are the missions here in Internet of Things? These are the missions? These are the missions? These are the missions? We are only the subscriber, no, not individual. Who is the subscriber here? Mission only. Who is the publisher? Mission only. Other mission. But we know that all missions are not same. Your television is different, your mobile phone is different, other application is different, broadcaster is different. So different missions are having different configurations. Data publishing is done by different missions having the different characteristics. Now we have to know that what exactly mission will publish the data, how with respect to this mission will collect the data, how these missions will understand that particular data. Data can be in any form. We have to see that how that data is getting accepted. So we have to see here there are different kinds of the devices. These are the different kinds of devices. So telecom devices, other type of devices. When you can see that the different kinds of devices depends upon the respective service requirement. Then how exactly internet will be used? For each and every type of services, devices, type of IoT formation will be different. For DTH, different type, YouTube, different type, sensor, different type. So we have to see that what is the kind of mission, how that mission will understand the data, but configuration will be same again. Publisher, broker and the subscriber. Let us see how exactly the IoT will emerge. IoT, we wanted to access the IoT if it is very small, if it is acceptable, if it is having the low power. All our mobiles will be using high power? No, yes. But mobile phone is the smallest device. It consumes battery power. If you connect some sensor to that, it collects smallest amount. So we have to see that whatever the IoT devices we try to make use, it should be smallest in size, it should consume the lowest power, it should be following the specific standard of application. Along with that, it should be cheaper also. It should be cheaper. What is the DTH set-top box cost? Around 300 to 400 rupees only. Anybody can purchase. It is the smallest in nature. Olden days it was very big, your TV was very big. Now it becomes smaller to smallest too. So in that case we have to see that the device should be smaller, consume low power, it should be standard and it should be having the smallest price. Now the technology, let us see the technology evaluation, the monitoring the data, how we collect and monitor the data. That somebody is publishing the temperature, that should be able to monitor very easily. It should not be difficult to the user, it should not be difficult to the machine, it should not be difficult to the user. Who is the machine user? Subscriber. He's there, no? I think you can come sit here. So monitoring the respective data, how to monitor the data? Because temperature every day is getting changed, yes? From morning smaller, less temperature, afternoon high temperature, evening again comes to the less temperature. So monitoring will happen into the bell curve. Similarly, how can we monitor the respective data collected by using the respective publisher? Then the remote control. You might have seen that every one of you may be using the washing machine at homes. These days you need not to call service person. Simply you can switch on your mobile phone, go near to it collects the data and sends to the service person, comes tomorrow directly. Otherwise automatically it will be repaired. Any software of the washing machine need to be replaced by default because of the device of your mobile phone, the software will be updated automatically. So the provision should be there to monitor, to operate, to report, so repair remotely also. So remote operation also required as part of the Internet of Things application. If you look into the technology requirement, initially we used IoT only for monitoring. What is the temperature? Somewhere the sensor used to be there. Somewhere sensor used to around the dashboard. You know the dashboard? Many of you will know what dashboard. The dashboard is only monitoring application. Actions cannot be taken. So initial days only it was like collecting the data, putting on the dashboard. It was only in monitoring requirement. Initially it was only the monitoring. Later it was adapted as part of the IoT controlling, optimization as well as autonomy also it was given to the IoT of all the devices. So based on that, everything is being collected as a technology evolution, starting from the monitoring to the providing the autonomy with the help of the IoT. We will be using more than one sensor, that is a different story. But as of now, the status of the IoT technology evolution, starting from the monitoring, it was originally, then it gone up to the providing autonomy to all the devices if required. Up to that scale, the technology is there. Another criteria is called the cognitive IoT. Now this room has a temperature, the fans are there. Now AC need to be switched on or AC need to be switched off. As I have given one example to you, the room temperature minimum normal room temperature 27 degrees, but room temperature crosses because we closed all the doors because of the fans. The temperature might have gone up. By default, by collecting the data with the sensors should give information to the air conditioners to start, switch on it and control the temperature, bring back to the 27 degrees. If it goes beyond that, again it has to increase the temperature, decrease the temperature in the AC, increase the conditioning. Means applying the intelligence, the cognitive levels, and we call now, we are reaching from automation to the now cognition also. See my dear friends, initially as of now I have explained to you IoT 1.0, it's a connected IoT platform. We call it as a connected IoT platform. As it is giving autonomy, thinking on its own, we are calling it as a intelligent IoT platform. We are calling it as a IoT 2.0. IoT 2.0, it is not only the providing dashboard, it is also giving information to the users and the subscribers with autonomy, with its own intelligence. When it is having its own intelligence, and we are calling it as a IoT 2.0, we also call it as a cognitive IoT. Yes or no? You are following me? Again, let me identify some blue shirt, please. You are blue. What is a cognitive IoT? Yeah. It is written there. So red shirt, your shirt. What is cognitive IoT? Automated, intelligent. Intelligent, it is thinking actually. Thinking on its own, deciding and giving the information, and we call it as a IoT 2.0, and we call it as cognitive thinking. Yes, whenever it's thinking, we call it as a cognitive, because collecting the data and deciding that what is the correct. According to the correctness, it is acting, behaving accordingly. Then we are calling it as a cognitive IoT or IoT 2.0. The original IoT was IoT 1.0. And we used to call it as a connected platform based IoT. It was simply connected, like a dashboard information, monitoring purpose. Now it is not like that. It is giving the autonomy by thinking on its own. That's why we call it as a cognitive IoT. So you can see the difference between these two. Connected IoT, common platform. Intelligent IoT, the platform. You can simply see that. Simple. The difference between these two. Where is the difference between these two? Connecting, yes, it is about connecting everything. It was connected. It was only dashboard. Information was just publishing. But this fellow now, IoT 2.0, It is not only publishing the data, it is alerting also. It is taking actions also. That's why we call it as a intelligent IoT, as a know everything, what to do, what not to do. What to do, what not to do.
Example, Google Map.
Google Maps.
Which tells that is the road busy with traffic?
No man, it's basically, exactly Google Map is different way. I have tried to explain, but Google Map gives that if yes, you can be partially a person who is not moving at 40 kilometers per hour velocity. By default, it indicates that it is the traffic. A person who is moving with 40 kilometers, it says that not having velocity. It simply not understands. By default, it is giving. But I have given one example: the automation of the devices. The temperature crosses. Temperature comes down. Taking the actions and inactions both together, we call the intelligent thinking and giving only whenever it is crossing.
So whenever the person increases the right way, automatically the navigation will correct us.
Yeah, that's alerting. That's what actions and the reactions both will be having there. So that then it obviously it is the intelligent fellow.
So normal ACs also they will attach to that.
Yeah. That's also IoT. Because of the IoT device, he understands, increases, decreases every activity. It will tell if there is a problem that has to be reported. Exactly. It has to identify the data. See, the completely knowing everything. He knows that when the temperature needs to be increased, when temperature needs to be decreased, it monitors and collects the data, processes it, and takes action. Everything he will report. He will report. Any action, I have given an example. There are many applications are similar to that can be. So, see, for collective you can see here the context of the same thing here. So, learning is very important. Based on the data input, learning is giving the input. After that, it collects the sensors, collection, analysis, recognition, prediction, response, self-extension. So, taking the actions also. Everything will be taken care by. So which needs a advanced system architecture, at the same time it strengthens the intelligence. So intelligence also we need to be adapted. See, system doesn't know. We have to tell system how it has to act. We have to learn it. We have to train it. Accordingly, it will take suitable actions. So then it is.
The cognitive radio, sir, same concept.
No, sir, cognitive radio is different story. Story is different completely. There is one more thing is like Internet of behavior. Internet of behavior. Now, one device, I think you may be aware of or not know, I don't know. For example, there is internet is connected over the network. The network. One network, internet fails. It goes to the another network. Whenever you are speaking over the internet, sometimes you will be getting the very speed, sometimes you will be getting with less speed also. So internet behavior means providing the services, providing the bandwidth depends upon the data requirements. Accordingly, internet service also, for example, a person it needs 1 Mbps, he will be provided 1 Mbps. One person needs only 1 Mbps, he need to be given that much only. So internet behavior also matters along with the intelligence. Just like that, we will not waste our bandwidth, whatever the bandwidth allotted to the respect. So for that particular purpose, we try to create the internet of behaviors, change of the activities. Everything will be monitored here when we call it as internet of the behaviors. Now let us see that there are small, I am not going to discuss all the applications, just let me give a glance. There are different applications we can take as a smart healthcare, smart home, smart city, smart logistics, smart factory, smart farm, smart autonomous vehicle, smart energy and the other services. Let us take one more example. Smart healthcare, monitoring all our body, including temperature, including all other activities in the body. Starting from the BP to the whenever I am jogging, whenever I am moving, everything related to the healthcare. Another one is I don't want to go in detail, okay? So we have 2.5 hours only. Another one is smart home, connecting all devices, connecting the fan, connecting the ACs, connecting to the microwave oven, connecting to your refrigerator, everything over the internet and operate them from the remotely. You might have heard the same thing? Yes, we can do that. So automation of all the home appliances, and we call it smart home. Smart city, monitoring when water will come to the taps, when water will go, when bus will come, when bus will go, when aeroplane will come, aeroplane will go, when train will come, when train will go, when will be the food vendor will come, where is the food vendor, where is the traffic, where is the policeman, where is the hospital, where is the doctor, entire monitoring of entire the city, including the garbage to the electricity. Everything will be automated and we call it as a smart city. Smart logistics, you know already, every one of you experienced this one by using the Amazon, Flipkart, Alibaba, everybody, where the respective product is available, from where it is dispatched, where it has reached, where it is currently. It is delivered or not. Money is paid or not. It is good or bad. Everything is connected. So logistics can be monitored from which place to which place. You may be traveling through the trains. You might have seen that where is my train now. Where exactly your friend is traveling through your train. Where is my friend's train now? You are monitoring, yes? In which platform it will be there and where it exactly is happening, where it is getting stops. Everything can be seen over there. Smart logistics. Whenever you are sending some parcel, postcard, you can monitor that where exactly my postcard is today. Smart factory, connecting all machines, all applications with the help of automation. With the help of IoT devices. Switch on that IoT machine at this time, complete pack at this time, and switch off the machine at this time. Monitor that one remotely. Everything can be automated. Smart farm, agriculture also, when the crop is need to be laid, when the water need to be supplied, when pesticides need to be supplied, when the cutting need to be done, when it has to go to the market, when it has to be sold, what is the rates, everything can be monitored. Again, that is the smart farm. Autonomous vehicle, this is a very much growing these days, and tomorrow every one of us will be using this one. So providing the autonomy to the steering, you can simply say that. But it is very difficult task, but we are going to succeed into this autonomous vehicles. Smart energy, electricity generation to the electricity consumption. How many users are there? How much energy I need to generate? If you give this information to the power generators, you can easily generate that much only. What exactly happening now? Energy is getting generated and we are not using. This is happening. Because of we don't have that much storage, we are not generating, we are not consuming. So now by using this IoT, we can, how many number of customers are there? How many number of generators are there? Both can be balanced. This is the smart energy. Then major IoT services as can be divided into two types, the personal IoT or public IoT. So personal IoT means the applications are working for me only. Public IoT is that information is going to give everybody. For example, temperature, it is not only for me. Temperature can be given to anybody. But my fever is my personal thing. I only must know that. If I am having some disease, I only must know that. Private IoT. I use some sort of devices and the devices gives information to me only. So we can create this particular IoT in two forms, as a public IoT, another one is the private IoT. I would like to know somebody's, my relative's temperature, medical health requirement, I privately will take care. But DTH service also your private IoT only. So you can configure into two types, the public IoT as well as the private IoT also. Another one is that industrial IoT, as I have also shown the example to you. What are the different type? All industries of IoTs are not same. Manufacturing industry is different, healthcare industry is different, and every depends upon the type of industry IoT can be applied. Public IoT and private IoT I have already explained to you. IoT components. So now it is very important what are the components we use in IoT? What are the three components of IoT? Publisher, broker, subscriber. These are the basic three components. But I am generalized the same thing in the name of publisher, subscribe, broker and the subscriber. But if you look into the technical requirements, there are different type of publishers are there, different types of brokers are there, different types of subscribers also there. So in that case, we have to divide into the same thing here. You can see, my dear friends, see all these are the applications. Yes, you can see here. These are the applications, or maybe you can say that publishers. Then it is basically the network providers. There is a LTE is there, 5G is there, Wi-Fi is there, signal, some connection between these two. We are giving over to the cloud is here. Cloud is there. All data is connected over this and it can be given to the users and the subscriber wherever it will be used. So in that particular case, we have to look into that different types of the technical requirements are there. So now everything, whatever we did up to here, everything is basically belongs to IoT. Then we can adapt with the respect to services as the mobile services, maybe stay in place or moving from place 1 to place 2, then collect the data over the cloud, apply artificial intelligence, provide the security to that as well. So by connecting all these things together, we have to make use of the new value-based application. So where you can identify the respective data, how to connect the data, how to use the data. So now let me make you understand here. These are the actuators. There is the physical object. There is a internet. Now, my dear friends, some of you please tell me, who is the subscriber here? Who is the subscriber here? First of all, you forget about this fellow, please, for a short while. Let us make this one first. Who is the publisher then? Publisher. Actuator is a publisher. Sensor is a publisher. Where is the broker? Sensor is a broker. Here is a broker connected. After this one, broker will be there. So this is basically connecting. Internet is there to connect there. Connected. Currently, there is no broker. Okay. So all are only the subscribers and publishers publishing the data. Publishing the data. See, directly it is not publishing the data. Internet is not there. It is taking help of some particular object, physical object, who is collecting the data and sending over through the internet to the broker. From the broker, it will be going to the subscriber. Now, the data is only getting collected here. Now, let us see here in this case. In this case, let us see. Now, what is this fellow? Sensor, data getting generated here. Here, what is exactly happening? Different kinds of data getting generated. You can see here, rain data. Then, what is it? Some sensor data, timing data, or other application, and connecting over the internet. So, what is there over the internet here? Cloud. Publishing over the cloud. Now, whenever it is getting published, what kind of data we can publish? What kind of data we can publish? So, it can be machine-to-machine wireless networks, embedded devices, the vehicles, agriculture, energy, security, building management, telemedicine, the smart homes, and everything. So, everything can be connected together by using the single application as well. But it will become very much complex. To avoid the respective complex, it can be divided. Applications of the respective nature can be individual in nature. For home automation can be separated because my home is not related to another somebody's home. I don't bother somebody's home, so my devices should not be connected with somebody's phone. So we can segregate, we can separate each and every application, then we can try to look into that in the name of the intelligent environment. So sensors, there are different kinds of sensors are there. So starting from the temperature sensor, water sensor, humidity sensor, barometric sensor, pressure sensor. You can take care of the type of application according to that. The sensor data can be collected. You can see here, my dear friends, the force, the load, the torque, detecting sensor, quite brother. The leaks, the electric, acceleration, ambient, the position, motion, temperature, humidity, acoustic, chemical. Various sensors can be collected, but only one thing we must remember, all the data, whatever we are collecting, may not be similar. May not be similar. The data need to be brought to the similar stage whenever we are publishing it. For that particular purpose, we need to make use of a transducer which converts the data into one form to the acceptable form. The temperature, humidity is there, humidity cannot be taken there. We need a transducer of humidity, collects it, then converts it into the form. So there are two kinds of sensors will be there again. Connected in the form of itself with the transducer. For example, take the thermometer. If you keep your thermometer in your arms, obviously it collects temperature to the digital. Blood pressure also the same thing. So we have to make use of a suitable sensor which can give the data, not only give the data, my friends, it transmits the data over the publisher. And so it need to have a connection device as well. When we have a connection devices, then only we can connect one device to another. So the sensor is not only independently sensing the data, it needs to be convert the data into acceptable form. The acceptable form by the broker. Broker must accept, so that it must be a inbuilt the transducer to the acceptable form. So collection of the data, as I have told that. So I think again the actuators only depends upon the data actuation. The smart sensor, again I have told you that collect the data, give the correct form. I don't want to do everything. So there are specific sensors are there. Specific sensors. So sensor one is called the radar sensor. Anywhere you have seen the radar? Huh? Madam, anywhere you have seen the radar? Madam? Dadangi station, yes, there is a radar. What radar it is? Weather radar. So Dadangi is very famous for detecting the weather, I think so, as per my knowledge. Not only that, Dadangi is very famous for looking at astronomical requirements. But a radar is basically range detector, basically. It's a range detector. So another is a range detector with the help of radio waves. Another sensor is called LIDAR sensor, light detection and ranging, from where the respective light is coming to me and what is the distance between me and the respective light. And another sensor is called 3D shape recognizer, laser and cameras, as well as the MEMS and access controller. So depends upon type of sensor we use, and that, as I said, that it should be smart. It's not only sensing the data, not only collecting the data, it needs to translate to the respective acceptable form by the publisher, broker. Another sensor is called passive infrared sensor. Whenever some light comes into that, it has to infrared, it has to record the infrared sensor. And the CDS sensor, the thermistor, as temperature sensor, all over the whatever the temperature detectors or whatever thermometers are there, obviously they will be used with thermistors. Load cells, accelerometer, it will be there in our mobile phone also. It detects that velocity based on the specific force applied onto the body. Gyroscope sensors, a gyroscope or gimbal, so it detects that the attitude of a body, and we call it as a gyroscope. It will be pitch, roll and yaw will be there, and will detect the attitude of the body. If I am moving front, going backward, going left, going